All right, in this video, we're going to be doing our calculus review. All right, so we're going to be going over derivatives, critical points on a graph, partial derivatives, finding limits using L'Hopital's rule, and finally we'll go over integrals. All right, so let's go ahead and just dive right in. And let's talk a little bit about derivatives. All right, so when you find a derivative, the notation is going to be d over dx. This variable here is what you're taking the derivative with respect to. And when you take a derivative, you're actually finding the slope of a tangent line at a specific point. All right, so if we had the function f of x equals 10x to the fifth plus 4x cubed minus 7x squared plus 3x minus 10. And if we wanted to take the derivative of that, we're going to use this f prime of x notation. All right. And so what we're going to do, kind of the cheat way without using the definition of a derivative, you're going to take your power, bring it down out in front, and multiply it by everything. And then that power, you subtract 1 off of it. So again, bring your power out in front, multiply it by what's already there, power subtract 1, minus bring your power down in front, times what's there, power minus 1, plus, on an x here, your power is 1, so you're going to bring the 1 down in front, times it by what's already there, subtract by 1. And then for these, since there are no variables associated with it, the derivative goes to 0. All right, and then we can just simplify. So 50x to the fourth plus 12x squared minus 14x to the 1 plus 3x to the 0. 50x to the fourth plus 12x squared minus 14x to the 1 is just x, plus x to the 0 is just 1, so that ends up being 3 times 1, which is just 3. And that would be your derivative. All right, so if you wanted to find the second derivative, so f double prime of x, you would just take the derivative of the derivative. So we're going to take the derivative of this right here. 4 times 50x 4 minus 1 plus 2 times 12x2 minus 1 minus 1 times 14x 1 minus 1 plus 0. And that would be 200x cubed plus 24x minus 14. And that would be your answer. Now, if you wanted to find the third derivative, so you do f triple prime of x would just be the derivative of this line. All right? So, if you wanted to find the slope of the curve where it crosses the positive x-axis, we're first going to find that point on the x-axis. So we're going to plug 0 in for y into the original equation and solve for x. All right, so I'm just going to go ahead and do that really fast. And you're going to get x equals 1. All right. Now, if you don't know how to find that, we cover that in our roots of equations video. All right. So x equals 1, so we're going to go ahead and plug this right here into our first derivative equation, because our first derivative is the slope of the tangent line. So we're going to get that f prime x equals 50 times 1 to the 4th plus 12 times 1 squared minus 14 times 1 plus 3. So then we'll get 50 plus 12 minus 14 plus 3, which is going to be 62 minus 11, which is going to be 51. And that would be the slope of the tangent line at x equals 1. All right. So let's go ahead now and give you one to try on your own. All right, so I want you to find the slope of the curve y equals 3x squared plus 2x minus 1 at the point -1, 0. So go ahead and pause the video now and try this on your own. And you can check your solution with our solution PDF below this quiz. This will be number 1 in that PDF. All right, so let's jump now into critical points on a graph. Oops. All right, so you're going to be able to find your critical points where f prime of x equals 0. Okay, so you're also going to be able to tell if those critical points our mins or maxes by using the second derivative of x. If that's greater than 0, you're going to have a minimum. If f double prime of x is less than 0, you're going to have a max at that point. All right, so for example, these critical points are going to be where they change curvature. They're also called inflection points. So we're going down, and then we're going up, and then we're going down, and then we're going up. So it's where it changes from going up to down or down to up. Now this here would be a max. This would be a min. This would be a min. And this would be a max. All right. So let's go ahead and look at an example here. If we've got f of x equals 1/5 x to the 5th plus 2/3 x cubed minus x to the 4th minus 4x squared plus 10. And we want to find the critical points and identify if they are a min or max. All right, so the first thing we're going to want to do is take the derivative of this. So f prime of x is going to equal 5 times 1/5 x to the 4th plus 3 times 2/3 x cubed minus 4x cubed minus 2 times 4x plus 0. Simplify that, we're going to get x to the 4th plus 2x cubed minus 4x cubed plus 8x. Forgot to subtract 1 on that one, so that should be x squared right there. That should be x squared right there. Okay. Yeah, we're good. We're ready to go. So, again, just reviewing, you're going to find your critical points or your points of inflection, or f prime x equals 0. So we're going to go ahead and plug 0 in for f prime of x. So we're going to get 0 equals x to the 4th plus 2x squared minus 4x cubed plus 8x. And then we're going to solve for x. So to do that, I'm just going to go ahead and pull an x out in front. So get x cubed plus 2x minus 4x squared plus 8. And I'm going to bring the 0 to the other side just because I'm more comfortable working with it over there. And then I'm going to go ahead and break this down into 2 groups. So I'm going to do x times x cubed minus 4x squared plus 2x minus 8. That should be a negative right there. Okay. So you'll be able to see how easy it is to drop negatives. So just beware of that and kind of double check yourself as you go through, like I have been. Okay, and then once I do that, I can go ahead and pull other stuff out of these. I'm going to bring this up here. So we're going to get x times x squared x minus 4 plus 2x minus 4 Now once we reach this point, since this is a like term in both of them, we can treat that as like a u. All right, so we're going to say let u equal x minus 4. So then if we rewrite that, we're going to get x squared u plus 2u. So then we can go ahead and combine like terms. We're going to get x squared plus 2 times u equals 0. All right, and then we're going to go ahead and replace our u back in with what we set it equal to up here. So x times x squared plus 2 times x minus 4 equals 0. So then we can set all of these individually equal to 0. So x equals 0, x squared plus 2 equals 0, and x minus 4 equals 0. So this here, we're going to get x squared equals a negative 2. Take square root of both sides. When you take the square root of a negative number, it becomes an imaginary number. So we're not going to have any roots there. And then here we're going to get x equals 4. So we've got x equals 0 and x equals 4. All right, so those are our points of inflection. Now we need to determine if they're mins or maxes. So we need to find the double prime of x. So we're just going to take the derivative of the first derivative, which was this right here. All right, so we're going to get 4x cubed plus 4x minus 12x squared minus 8. All right, so then we're just going to plug x equals 0 in and then x equals 4 in to determine if there's a min or max at that point. So let's go ahead and start with x equals 0. And we plug all that in, we get f double prime of x equals negative 8, which is less than 0. So we can come back up here, and f double prime of x is less than 0, then we have a max at that point. So we know that there's going to be a max there. We plug in x equals 4. We can get f double prime of x equals 4 times 4 cubed plus 4 times 4 minus 12 times 4 squared minus 8. And when you plug all of that into a calculator, you get that equals 72, which is greater than 0. So we have a min at this point. So on our graph, we're going to cross at 0 and then 1, 2, 3, 4. All right, we're going to have a max at 0. So we're going to have a curve that opens down at that point. And then we have a min at 4. So have something that looks like that. All right, so max somewhere along 0, a min somewhere along 4. All right, and this point here doesn't necessarily have to be at 0. It could be up here, it could be down here, just as long as it stays consistent. You can figure out where it'll cross the x-axis if you plug 0 in for y into the original equation. All right, so if you ever need to graph something. But that would be how you find your inflection points and if they're mins or maxes. So let's go ahead now and give you one to try on your own. So find min or max of y equals negative 3x squared plus 4x minus 6. And identify if it has a min or max. All right, so pretty much what we did just above. All right, so go ahead and pause your video now, try it on your own, and check your answer with the solution provided in the PDF below. And this will be number 2 in that PDF. All right, so let's now talk about partial derivatives. All right, so you're going to take the derivative with respect to one variable and treat all other variables as constants or as just an ordinary number. All right. So for example, if we had f of x, y, z equals x squared, y squared, z plus 4 x, y, z squared plus 5x to the 4th minus 3y, z. And we wanted to take the partial derivative with respect to x. All right, so now the only thing that are variables are now the x's in each of these, okay? Everything else you just treat as if it was a constant, like this number out in front here. All right, so when you take a derivative normally, if we just had 4x squared and we wanted to take the derivative with respect to x, then you would just bring this number out in front, multiply it by all of the constants, and then take your x and subtract 1 off of that. So we're just going to do the same thing. All right, so our variable here is going to be x. So we're going to bring that 2 out in front, multiply it by x, subtract 1 off of the power, and leave everything else as constants are the same. So y squared z plus x in this case is right here. So that's just a 1, so that's going to be 1 times 4. X to the 0 power, leave everything else the same, y z squared, plus, this one's just regular, so 4 times 5x cubed. And now there's no x's here, so that's just like having a whole number which goes to 0. So that's going to be minus 0 on the end. All right, and then you can just simplify. So 2x y squared z plus 4 y z squared plus 20x cubed. All right, so if we wanted to take the partial derivative with respect to y, 2 out in front, x squared yz plus 4 x, y goes away because 1 minus 1 is 0, z squared. There's no y's here, so that just goes to 0 minus 3z. So 2x squared yz plus 4xz squared minus 3z. And then the partial derivative with respect to z, we're going to get x squared y squared plus 2 times 4 xyz plus 0 minus 3y. So that would end up being x squared y squared plus 8xyz minus 3y. All right, so those would be all the partials with respect to x, y, and z individually. All right, so go ahead and try one of these on your own. So we're going to get, say we have z equals 4x squared y plus 2xy squared minus 3xy plus 4x squared minus 2y. And you want to find the partial derivative with respect to x. So dz dx. All right, let's go ahead and pause your video, work that out, and check your answer with our solution PDF found below, and it'll be number 3. All right, so now we're going to talk about limits, specifically using L'Hopital's rule. So first, let's just review what a limit is. If you've got something like find the limit as x goes to 1 of, I don't know, 4x squared over 3x, you're just going to plug in 1 everywhere there's an x. So 1 squared over 3 times 1, that's going to be 4 over 3. So that would be your answer. All right, but if you come across something like this, limit as x goes to 0 of 9x to the 4th plus 3x squared all over 2x cubed plus 9x squared. Now when we plug in 0 everywhere, we get 0 over 0. So a lot of times people will just go, oh, okay, so the limit equals 0. But that's not right. When you end up with a 0 over a 0 or infinity over infinity, you have to use L'Hopital's rule. To simplify your limit. So to use L'Hopital's rule, you just take the derivative of the top and the derivative of the bottom. So when we do that, we'll end up with limit as x goes to 0 of 36x cubed plus 6x all over 6x squared plus 18x. Plug 0 in, we still get 0 over 0, so we need to use L'Hopital's rule again. And we'll get limit as x goes to 0 of 108x squared plus 6 all over 12x plus 18. This time when you plug in 0, you get 6 over 18, which ends up being 1/3. So that's your answer, not 0. All right, so go ahead and try one of these on your own. So find the limit as x approaches 0 of 4x cubed plus 3x squared minus x all over 2x squared minus 4x. All right, pause the video, work that out, and check your answer in the solution. It's going to be number 4. Now finally, let's talk about integrals. All right, so integrals are used to find the area under a curve. All right, so there can be indefinite integrals, and these have some sort of bounding limits on them. All right, so if we have the equation y equals x squared minus 3x plus 4, if we found the indefinite integral of that with respect to x, you're just going to kind of undo what we were doing in the derivatives. All right, so how you're going to do this is you're going to increase your power by 1, all right, and then divide by that number. So we've got x, increase the power by 1, and then divide by that same number. Again, constants will stay the same, so we'll have 3x, increase that power by 1, divide by that number, plus 4x increased by the power of 1, so we'll just have x out there on the end. Now, because it's indefinite, we're going to have some constant out here on the end, so plus c. Always remember that, because if we were to take the derivative of this, we should end up with that. All right? And so there is going to be some constant on the end that just goes to 0 when you take the derivative, so you'll end up with that. All right? Now, if we wanted to take the integral of this, but only between 1 and 5, you just take the integral the same way. So x cubed over 3 minus 3x squared over 2 plus 4x. Instead of adding a c, we have it bounded by 1 and 5. All right? So then you're just going to go ahead and plug 5 in for x and then 1 in for x and subtract the 5 side minus the 1 side. All right? So this is going to look something like 5 cubed over 3 minus 3 times 5 squared over 2 plus 4 times 5. Subtract, now you plug in the 1, so 1 cubed over 3 plus 3 times 1 squared over 2 plus 4 times 1. All right, so you'll end up with, if we work this out, 125 over 3 minus 3 over 2 times 25 plus 20 minus 1/3 plus 3 over 2 plus 4. And if you simplify that even further, we're going to get 24.167 minus 2.833. And we'll get that the area under the curve between 1 and 5 is 21.33. And that would be your answer. All right. So you can go ahead and try one of these on your own. So find the area under the curve of y equals negative 2x to the fourth plus 3x squared minus 4 between x equals 0 and x equals 5. So pause the video now, try it on your own, check your answer with the solution. This will be number 5 in the solution. All right, and then finally, just some things to be aware of. Make sure you can find gradient, divergence, curl, and vector field in your reference handbook and be able to plug and chug. So plug numbers in and find an answer to any of those. We're not going to go over them, but if by chance they did show up on your exam, make sure you can, use Control F and find those equations and be able to plug some numbers in there and find the answer. All right, so that sums it up for our calculus review. Go ahead now and take the quiz and test your knowledge. I would recommend doing the quiz until you get 100%, and also that it takes you probably less than 10 minutes to do this portion. So keep doing the quiz until you get 100%, and you can do it within 10 minutes.